Welcome to the Data Pioneer session. It is a really, really specific title, so I have no idea what you think you're coming up for, but hopefully we're going to have a really interesting discussion anyway. My name is Maxine Mackintosh. I am a PhD student at the Alan Turing Institute and also the co-founder of an organization called HealthTech that looks to get more women in health innovation. I'm afraid I missed this morning, so I suspect every single kind of wet rain joke has been made, but I am so wet. I'm wetter than Matt Hancock's dreams about being Prime Minister, so I really hope that you can all join me in just being corralling together and just taking just being a bit damp together. So on that, I appreciate it's a kind of slightly icky, dank situation, so I'd like all of you to stand up. There is some audience participation. Please all stand up. So just do some fast feet. We're just going to do a micro exercise class. Just jog on the spot. Get more vigorous. To the people in orange, you are part of our zone. Oh, look at those orange men who have 0% body fat. Keep running. And then just to make sure that you've bonded with the people next to you, if you don't want to be touched, that's okay. Just go like this or turn to the next person next to you and just judge them. Okay, you can all take a seat now. So now we are a damp and steamy room, which I think is probably worse. Anyway, so the structure of the session is, I suppose, much like all the other sessions, we're going to have, I'm sure, ebullient keynote from Dom King, who is the health lead for DeepMind Health, and followed by about 35 to 40 minutes of panel. Just to let you know, obviously, CogX is not allowing audience questions. However, I will keep my Twitter open at maxi_mackie. So if you do have any really burning questions for our panelists, please do tweet at me, and I'll keep an eye on my Twitter whilst Dom is speaking, whilst obviously listening to every word that Dom says. I will keep an eye on my Twitter if you do have any burning questions, and I'll try my best to incorporate them. So, without further ado, I would like to welcome Dom to the stage. Can we have a huge round of applause for Dom King?
Great. So no audience participation from me, I promise. So to kick things off, actually, I was just speaking to Kenji, and we gave a talk a couple of years ago at CogX. And it's worth showing this slide again, because for those of you, and I think it's probably most people in this audience who care about healthcare, this was the exact slide I showed 2 years ago. These are some of the health system challenges we're facing. The continuing lack of delivery of evidence-based healthcare, doctors and nurses burning out, care seems fragmented, unwarranted variation. So surely technology in the last 2 years has solved all of these. Well, not at all is the answer. And if anything, for those of us that care about healthcare, actually what we're seeing is actually things maybe even getting a bit worse. So in the last couple of years, we've seen the life expectancy rate in the US fall. I was part of a meeting a couple of weeks ago hearing about some patient safety metrics in the NHS getting worse over the last 2 years. Burnout, worse in the last 2 years. So, we may have been excited a couple of years ago talking up healthcare technology and AI, but it hasn't made that much difference if you're on the front line. So question I have for today is, can digital technologies and AI help solve some of those challenges I just showed? I'm going to say a confident yes, and say thank you if you all agree. You've been a great crowd. But why do I think we should be optimistic? I was probably, to be honest, optimistic 2 years ago, but why do I think we should be more optimistic now? So firstly, I think there's been, and I caught the tail end of the questions in the last session, and I agree with everything that was said. There's been remarkable progress in the underlying science of AI. So this is just from DeepMind, up to 10 plus Nature or Science papers in the last couple of years. A couple of years ago, we were talking about Atari games or beating the world champion at Go. That was with a lot of human expertise involved. Subsequently, Nature papers showing these algorithms effectively learning to become the best chess player or Go player of all time within hours with no human input. Secondly, I think Kenji was talking about this, access to improved compute and tool and tech tools that used to only benefit people that worked at Microsoft or IBM or Google, and now you can access the same types of tooling and the same types of infrastructure if you're a startup or working in academia. And in practice, we know this technology works. We know this. Sundar, the CEO of Google, said we're moving away from being a mobile-first to an AI-first company. We know in these billion-user products that this technology works. And I remember one of my first meetings with Mustafa, one of the co-founder of DeepMind. He said, healthcare is so much more complex than everything else. Unless you see it working elsewhere, whatever it is, it's not going to work in healthcare first. And I think that actually holds true. So the progress we're seeing in medical imaging, I think, is based on the progress we've seen more generally in computer vision that we see, for example, as an established consumer product in photos. And I also think that, you know, the ecosystem, particularly in the UK, which, I mean, I'm going to say I think is the best place to do this work, has really advanced over the last couple of years. So just this week, a couple of days ago, Ellie, who's here from Reform, Simon spoke at Reform event, getting the NHS ready for AI. The brilliant work Jess, Indra, and others have done on code of conduct. I think this is actually putting the details in place for how this stuff will actually work in the future. So I really think that, and you may or may not agree, that for the first time actually, despite the excitement and enthusiasm people talked many years ago, that there's enough intelligence, there's enough compute, the data is better quality, and there's a structural support, as set out in this paper that was published in JAMA a couple of months ago by one of my colleagues at Google, to actually make real impact for patients. So I like to think at least about artificial intelligence as being this general purpose technology. In the same way that electricity or the internet transformed many different industries, we're going to see sea changes in how different types of healthcare. This isn't not just going to improve genomics. It's not just going to improve radiology. It's going to cause a sea change in how we do all types of medicine. And we're already seeing some of this technology being widely applied. And I'm just going to give you a run through of what we're doing, not just at DeepMind, but across Google in some of the projects we're doing. Now, it's a really important part of the culture. There are many hundreds of people working in healthcare across Google, and you may have read news in the last couple of months about those efforts coming together. We're absolutely committed to the highest standards of science and peer-reviewed research and the work we do. One of the reasons I say this is because those academics in the audience will know, and startups too, how painful the peer review process is. So in many ways, what I'm presenting you, I think, is 8 to 12 months old. I would love to tell you about some of the most recent advances we've made, but we want to be able to do that in a place where we have research and the ability for people to question and discuss that in peer review process. So medical imaging is the place where we're seeing the most progress. I'm just going to run through a couple of the projects and areas that we're working in. 2 million people in the UK suffer from sight loss. Much of it is preventable. Diagnostics are actually allowing us to identify people with treatable early signs of sight loss much earlier. I think one of the landmark papers was actually done by some of my close colleagues now in another part of Google, in a group called Medical Brain, who published this paper in JAMA, which is one of the top medical journals 3 or 4 years ago, and showed the ability of an algorithm, I think really for one of the first times, to reach expert level performance in 2D eye scans. Now, lots of you will have seen these type of ROC curves now. I'm not going to go into great detail on the results here, but this was the first paper that I think caused a lot of people to sit up and go, actually, this technology could start making a real difference. From the DeepMind side, we actually started looking at 3D eye scans, which these technologies are becoming very commonplace. Next time you go for an eye test, it's likely that the optician that you'll go to will have one of these special 3D types of scanners that you used to only find in the leading eye hospitals. And some interesting things I think worth pointing out from this paper. This didn't get published in Nature Medicine because we reached this expert level performance. But it's worth pointing out that human variability is huge. So number 1 and 2 are 20-year expert professors of medical retina at Moorfields, the world's, what we'll say is the leading eye hospital. 7 and 8 are exceptionally good optometrists. Yet look at the variability in their performance, and our performance up here is at least statistically non-inferior to 1 and 2. The other thing is that this did not create a huge burden of false positives. So while we picked up all the urgent cases, we didn't flag thousands of cases that had no problem. So we're very excited about this work, but the reason this was published in Nature Medicine was not because of this performance, which lots of groups, including in this room, are doing. It was for some of the progress that we made in kind of dealing with the black box issue of these algorithms. So not just are we providing a result, but we're also showing in a cartoon-type way to the clinician where we think the problem is. So the red you see is neovascularization of the retina. And not only are we saying we think this patient's got a problem, but we're also suggesting where that problem may be. The 2D work, so we're now planning on the clinical trials with our colleagues at Muirhead. The 2D scanning work is now actually being used in India and Thailand, places that have an even more pressing need for this expertise. And we're starting to see some really promising results from this work. So a lot of the initial focus has been on diagnostics. Can we diagnose someone has got a problem, hopefully at an earlier stage? The flip side of diagnosis is that you want to be able to treat people. If you're unfortunate enough to get head and neck cancer, the mainstay treatment is radiotherapy. If you need radiotherapy, it can take an expert about sometimes up to 6 to 8 hours to carefully trace out all the organs that you need to avoid when you're focusing the beam of radiation at the tumor. In a preprint publication, peer-reviewed paper coming out soon, we showed, and it's always interesting how this stuff progresses. So a couple of months ago we were expert level performance in 19 out of 21 organs of the head and neck. And as of the last few weeks, we're at expert level performance in all 21. So this is the ability for a system within seconds to carefully segment out all the organs in the head and neck, such that a radiotherapist can then make sure everything's fine in minutes rather than hours. A paper that was published a couple of weeks ago, can AI detect lung cancer? The point I'd like to make here is whether it's breast cancer, lung cancer, colorectal cancer, the earlier you pick these things up, the better it is in terms of survival and ultimately the costs of care. We diagnose way too many cancers in the UK at stage 3 and 4, at which point the survival rates and the costs are huge. Much better that we're diagnosing these earlier at stage 1 and 2. And so in this paper, we're able again to show expert level performance at diagnosing lung cancers. This again was published in Nature Medicine. Similar ROC curves to the many that you will have seen before. Another area that I think is really ripe for progress is in pathology. So I used to be a breast cancer surgeon in my past life, and I well remember in the service that we ran, we would looked after all the patients in kind of northwest London, and we would, in the weekly meeting, you would get to maybe patient 60 out of 100. And then the pathology team would say, that is all we had time for this week. And so those 40 ladies would have to wait another week of stress and anxiousness because there wasn't enough people to look at these slides. Now, in an ideal environment, you would be doing a biopsy and doing pathology at the same time and giving a diagnosis right there and then. But that is just not possible with the current workforce challenges we have. So again, in this work, reaching expert level performance and looking at the pathology in the lymph nodes under the arm. Another thing which I think is really interesting is, what's your gold standard are you comparing this to? If you compare it to a pathologist with unlimited time, well, you're still beating him or her, but no pathologist has unlimited time. They have literally 5 minutes, 5 minutes, 5 minutes. And so when you simulate that type of busyness and context, their performance falls significantly. The performance of the algorithm doesn't. But one of the things that I think becomes really important if you're a startup or if you work for Google, which is a product company after all, is how does this stuff start making a difference in the real life, in the real world? And one of the challenges in the real world is that most digital pathology, unlike radiology, at least in developed health systems, is still done on manual slides. So this is like a neat example of some of the work our teams are doing, where we're identifying as you go through the manual slides, all hooked up to clever systems, where the cancer or where the flag is. And these kind of things can very easily and often are missed. Now, the thing that I think is much more exciting about the future of this technology is not that we reach some type of expert level performance or the addition of these technologies alongside human expertise sometimes ups everything by a couple of %. It's the ability for these algorithms to see things that the human eye can't. And I think this is the first example of this that I've really seen in the work we've done, is using 2D fundoscopy to predict your risk of cardiovascular risk disease. So this is kind of interesting. You know, this is your eye. These are the blood vessels. It's not kind of surprising that you can pick up if someone's diabetic that they're kind of get changes in these blood vessels. We were able to predict better than almost all cardiovascular risk predictions just from a simple X-ray of the eye or an image of the eye, what someone's cardiovascular risk for the next 5-10 years was. And I have down here at the bottom gender AUC 0.97. What these algorithms can do is tell whether that eye scan belongs to a male or a female. Now, there's many easier ways of doing that, obviously. But there is no ophthalmologist on this earth who is able to look at that scan and say that is a male. Any ophthalmologists in the room? No, good. But there is no ophthalmologist in the world, so I'm reliably told, that can do that. So these algorithms are capable of seeing things that the human eye can't, and that's got interesting kind of ideas and perspectives when we start looking at other data types, of which medical records is another data type. Now, this is actually the area that I think we're going to see great progress in medical imaging. But I think medical records is actually where we can make a lot more impact and difference for patient care. And there's this kind of interesting, so much, for those clinicians in the room will be well aware of this, so much of what we currently have in medicine is a flag of someone's existing deterioration or problem. So the blood test that tells you have a kidney problem or a liver problem or pancreatitis is when there's end organ damage and those organs are releasing some type of chemical that you pick up. And there's this kind of interesting idea that us and many other teams have had, which is, well, we're collecting this huge stream of data now. Can we kind of go back in time a little bit and say, can we predict someone's going to get sepsis from acute kidney injury 24 or 48 hours before, or a chronic condition 5 or 10 years before? And these problems are, I would say, the big challenges, particularly in secondary care and acute care. Acute kidney injury, sepsis, these kill tens of thousands of our friends, family, and fellow citizens every year just in the UK, and cost billions of pounds. So in a paper published about 18 months ago, some of our colleagues demonstrated that using deep learning approaches, we could predict many of these things much earlier and more effectively than is currently possible. We at DeepMind have a partnership for the last 3 years with the Department of Veterans Affairs, which has the most comprehensive electronic medical record that we've at least ever found. And the results of this, again, premised by, we'll publish this in peer-reviewed press, is the most exciting work I've certainly been involved in. It is really the ability to predict patient deterioration and disease earlier than has ever been possible, giving the smart clinicians in this room and those working in the hospital, more importantly, a head start on treatment. But these types of technology will not make any difference to patient care or clinicians' lives unless we think about the way in which they're deployed. And that's very much, many of you will have heard about the work we do on streams. But this world of pages, fax machines, I know we laugh and joke about it. It is the truth of care as it still stands in kind of 2019, that the vast majority of clinicians in the NHS are prescribing medications in the hospital on paper and using pages to communicate with each other. So the reason we've built streams and dedicated so much time and effort to it is this idea that when we have the algorithms that can tell us that someone is about to deteriorate, we need to get that to the right clinician, the ability to send that alert, give the right contextual data, and allow clinicians to take action in real time. And on this work, we're very proud about the early kind of reports and anecdotal feedback we got back. Again, premised on peer review. We have an independent service evaluation of this work that's been happening at the Royal Free, coming out in the next couple of months. Again, we'll be really excited to share that. So I think I have, just in the nick of time, 2 minutes. These technologies, particularly when they come from a company like Google and Microsoft and IBM, do raise issues and concerns. we've got some of them up here: algorithmic bias, value back, data security, and privacy. I think it's important that we have open and frank discussions about these. And I think, in the last 2 years since CogX, we've really seen these places for us to talk around AI code of conduct, where there's so many familiar faces here, because we all get together and talk about the kind of future of healthcare AI. So I hope we kind of get some questions on these. I'm very happy to answer them. And back to you, Maxine.
A huge thank you to Dom King. Now, I'm aware that we've got lots of people standing, and I did a quick recalculation, and based on the number of people in this room, and of the men, and the fact that 45% of men have a chronic issue with manspreading, if all of you just went, we'd get 20 meters amongst us. So all these people could then sit down. So if you can just kind of shimmy on, close your legs, get close to one another, then all these poor people on the edges could have a wee seat. What space amongst health stage attendees, right? Oh, don't come up there. Don't come up there. No. Perfect. We still have some standers. Is there anyone else who... There's a seat down here. There's a space down there. There's 2 seats down there, depending on how big your bum is. Right, okay. Sorry for everyone else who didn't quite get that. Okay. So this session is called Data Pioneers. It's a really nice, humble, low-key title. So just to make sure that we're not too depressed about how terrible the weather is, we're going to give a huge data pioneer rock star welcome to every single one of our speakers. I know it's cringe. I might as well be an American. But can we have a huge round of applause, including whoops and cheers, for our first speaker, Kenji Takeda. The whoops need to get bigger, guys. We need more energy. No offense, Kenji. Right, so the next speaker, we have Rabia Khan. And our next speaker is Chwastowska. That's everyone. I thought there was an extra person. Scooch up. Perfect. So, obviously, Kenji, you were on the last panel. Can you all hear me? That's that bit better, isn't it? Yeah. So please, can you all introduce yourselves, your organisations, what you do, and, because we're amongst friends, a fun fact. Kenji, go ahead.
Sure, yeah, I'm Kenji Takeda, for those who don't know me from the last hour. So I work at Microsoft Research in Cambridge, just at the other end of the railway line, and I head up our academic healthcare and AI partnerships. Fun fact, before I joined Microsoft, I used to do research in aerodynamics. And I basically used to teach people how to design Formula 1 cars, as well as airplanes and spaceships as well.
All right, serious fun fact.
Hi, whoa, this is really loud. My name's Rabia. I manage the systems medicine team at Sensyne Health. So what does that mean? It means the team that's the interface of using EPR data to translate into the pharmaceutical drug discovery and development pathway. I'm a geneticist by training, so not the AI ecosystem. And fun fact is my PhD was injecting tail vein injections for mice with salmonella, so I can inject a mouse tail vein.
A skill you've always thought you needed, right? Yeah.
Hey, hello everyone. I'm Joanna. I'm one of the engineering leads on the Streams project that Dom was talking about. And fun fact about me is that I actually moved to London 2 years ago. So for me, the weather here is actually the improvement.
And obviously, Dom, we know who you are, but you are not exempt from a fun fact, I'm afraid.
It's always difficult when people ask about hobbies now when you get a bit older, because you don't really have any. But I have this, like my daughter came back and has had a school project, and that has led me to have this massive thing now about school projects. So I will spend the whole weekend. I'm one of those annoying dads that spends the whole weekend doing a school project. I bring it in, and all the other parents at the school gate are like, but I will go to any effort to make my daughter have the best school project.
Pushing down, there we go, fab. And I guess my fun fact is that thanks to Dom, I have now met my husband-to-be, so I'm eternally grateful to Dom. So many services he offers, your homework, matchmaking. Right, so you're on this panel because in some way you are working for organisations that are kind of pioneering. Obviously we've heard from DeepMind. But can I have a couple of minutes maybe from these three, about what is it that makes your organization particularly pioneering when it comes to AI in health. We started with you this time, so let's go to Joe.
Oh, sure. So before I joined DeepMind Health, I've been for quite a few years part of Google. And I think about the differences between the companies. Google uses AI across all the direct-to-consumer products. And that's amazing. But if you start thinking about healthcare application, there are so many much more important things that you have to take into consideration. Just to name a few, first of all, the evidence-based AI. So it's not enough to find something interesting and try it on 5% of users and see what the effect is. Actually, we want to be sure that whatever we introduce to the clinical setup is relevant and is actually helping the patients. Then the second thing would be interpretability. So what Dom has shown you, the 3D scans and actually this model that is built that helps the doctor to understand where the diagnosis is coming from. This is extremely important because we want to give them the power of making the decision, and we just want to aid it to some extent. And finally, the third and probably the most important part is the applicability of the research. It's not enough to have a great model that has been trained. It's very important to think about how to bring this model and make it useful for patients. So from the work that is happening in India to the streams and the future of healthcare, I think that those will be the three main differentiators.
Perfect. Thank you. Rabia?
Am I allowed two?
You're allowed 3 minutes to combination of 2 and 3. You do you.
Excellent. So I work for a company, it's AIM-listed, quite young, called Sensyne Health, and there's two very interesting things about the company. One is a business model whereby revenue from the partnerships that we generate, which I'll talk about in a bit, go back into the NHS. So we have the ability to use NHS information anonymized to actually deliver value back in. The aspect there is that we don't believe in selling into the NHS. We partner with the pharmaceutical industry to solve drug discovery and development problems. And that's really where I sit. And so the other really exciting thing about the company is it sits at the intersection of healthcare data and the people that are trying to build medicines and make a difference. And so trying to change the drug discovery and development pathway using NHS information.
Yeah, so Microsoft's been around for a while, and I think it's when you step back and think about it, I think most healthcare data and pretty much every healthcare organization on the planet uses Microsoft technology and has done for decades. And so we've been thinking really hard. Peter Lee, our CVP, was asked by Satya Nadella to think about how we can contribute more into the healthcare ecosystem. And so we're really focusing around three things. One of them is really breaking down these silos and really unlocking the potential of data through cloud computing. And then critically really empowering the people at the front lines of healthcare, empowering patients and citizens, whether that's in a hospital, in a very specialist unit like in radiation therapy, or in the pharmacy. We just announced a very big deal with Walgreens Boots Alliance. So about 80% of the population in the US is within 5 miles of a Walgreens chemist. And part of that alliance, clues in the name, is Boots in the UK. So how does the pharmacy actually, what can we do there to really help people and also then alleviate other downstream pressures in the health system. And then the third one is really moving towards precision medicine. So this morning, Sir Mark Caulfield talked about Genomics England and the great work they're doing, a lot of projects that we're doing around that as well. It's a journey, and within research that's particularly exciting, but that's really where there's really transformational potential in the future. So we've really thinking about how we can work across the ecosystem. We have about 180,000 partners worldwide, and we really think about individual boats doing kind of great work in AI, but Microsoft, we feel like we're lifting the tide for the whole healthcare ecosystem around technology, and particularly within AI now.
Kenji used a lot of the word ecosystem empowerment. You need to be careful on your buzzwords.
Okay, yeah. I've used them up.
In part of the briefing, we had a buzzwords rule. I shall not enforce it on this occasion. So a lot of the really interesting AI work is happening in secondary care, and when you look at the burden of disease, that often doesn't lie within secondary care. That lies in the social determinants of health. So can I actually start with Joe? What is it about secondary care that makes it a particularly interesting area to work on when it comes to AI?
So I would start from saying, actually, whatever we can do to prevent people from getting to secondary care, is, super important. So we should not lose the sight of all the preventive care that can be done. But for the secondary care, I think, for me personally, if you look at the slides that have been presented, it's amazing to realize that for the expert level clinician with 20 plus years of experience, they would see across their lifetime, hundreds of thousands of cases. They would be building their model to actually make the right decision at the right time. The question is, the doctor you will see at the hospital likely has maybe 5, maybe 7 years of experience. Can we build models? Can we use AI to actually help those doctors to have similar level of expertise as super experienced clinicians? And actually, the interesting thing that it can be observed is even during this famous game of Go, what Lee Sedol, even though he has been defeated, what he said is actually he learned something new by interacting with AI during the game. So I think there is like a huge field for people to learn and discover new things simply by interacting with AI.
So I've got a slight follow-on question that was echoed by a question from Axel Heitmuller, who tweeted a question at me, which is, his question was, how does digital actually shift the needle in this whole discussion? And I kind of wanted to ask the panel that, what are the problems that are really worth working on when it comes to AI and healthcare? Because there's a lot of kind of pseudo AI being applied to pseudo first world problems. So what sort of problems should big corporates or exciting big pioneering companies be working on when it comes to the healthcare space? Open to anyone.
I mean, I think it's kind of interesting if you go back to 3 years ago, or 3.5 years ago, DeepMind, which was a number of us who, Piers Keane, who many people know here from Moorfields, myself, people at Raw Free, we kind of went to the technology company. It wasn't just DeepMind, but they were kind of arms open, I guess. But I emailed Mustafa, a number of other people did, and said, we've spent 10 years in this problem, and we think this is a tractable area for artificial intelligence. We also think it's worthy of attention. And to DeepMind, we'll get dozens of emails a weekend, and we'll diligence some of them that look like there's some real passion and obvious potential there. But I think you have to listen to experts, and the experts are patients ultimately, clinicians and academics, and health systems. The NHS could, and this is something I've kind of encouraged when we've had discussions around what data sets should the NHS be building on. The NHS knows exactly what data sets it should be building. They're the areas where we face enormous challenge and an inability to deliver a continuing service. Mammography. Will we have a sustainable breast cancer screening service in a couple of years' time? Unlikely if we don't have AI-based approaches. So the NHS should be supporting and encouraging efforts in that space. Chest x-rays, hundreds of thousands of chest x-rays no one looks at. Some of them have the earliest signs of lung cancer in. So you could get a panel together or do more diligence if you want to than that, and very quickly say these are the 10, 15 big issues. I flagged up a slide which is from our own internal kind of strategy and consultancy work, which is what are the big problems we should be facing in the acute care setting. Acute kidney injury, sepsis, general deterioration, the ability to predict someone's length of stay, and the ability on discharge to say what's the chance they'll come back in the next 30 days' time. So, I think it's actually up for the system to be defining some of those problems, and the technology companies to be responding to that, not trying to do what looks the smartest or cleverest project.
Yeah, one of the interesting things at Microsoft is we think about impact kind of at scale. So again, we talk to all our partners, clinical, academic, customers, and try and identify those problems that can really make a difference, sometimes system-wide level. So we have a really interesting project called Project EmpowerMD. Certainly in the US, clinicians will, for every hour they spend with a patient, they'll spend 2 hours kind of embedded within the electronic healthcare record system, typing things up and looking them up. And so that project's really building what we call an intelligent scribe, so that while a clinician, be that primary care or secondary care, is talking to the patient, then in a privacy-preserving way, that's then essentially being analyzed and then written down within the normal doctor's kind of notes so that can automatically be transcribed. The doctor can then modify it. So again, the potential impact for that across healthcare systems, every healthcare system, is it frees up the doctor from sitting there typing into some old style kind of user interface, so they can actually talk to the patient, and then it's a much more consistent data that can then go into a machine learning problem. So thinking about some of these problems at system-wide level to have some real impact, and then particular use cases across, say, primary care and secondary care is really important. The gains there, as a company we work with called Kenji, working with NHS Glasgow and Clyde, around COPD is the second biggest sort of intake of patients into A&E. So they've built a system where the patients get some wearables and technology within the home, which then gets sent to the cloud, and machine learning is applied. So the clinicians can look at that, they can phone the patient, they can send them what they call a rescue pack to stop them then having a hospital admission. So it's a really interesting interplay between primary care, secondary care, and in the home. For again, it's sort of COPD seems like quite a sort of kind of neat rare disease, but actually the impact of the health system is quite broad. So thinking really hard, but really being guided by clinicians, patients, being very human-centric about what we can do, I think is kind of core to how we think about this.
So can I ask a slightly mean question? So to what extent do you feel you can really solve those problems? Because on some degree, how can you really ensure clinical safety if you're building these models that no one really understands on decades of ropey NHS infrastructure and underfunding, which you would obviously never be able to comment on as a supplier. But there's some degree to which, if you can polish a turd, it's still a turd, and you can build all these fancy models, but you just don't have the infrastructure or disposable. So obviously an example in DeepMind is that you guys spent millions on curating that Moorfields data set, and as a result you're able to do incredible work, but you can't do that every single time you want to apply some really impressive models.
Yeah, but this is, you're looking at me, so I'm going to respond to this. So I think Moorfields, I will proudly say, I think is an exemplar of what you can do in this space, which is recognize that actually the real value in there, there's 1,000 eye hospitals around the world doing those scans now. Like the value isn't so much in the data, but in the expertise that comes round with it. No one has curated a data set as high quality as Moorfields have now with that data set. It's powered research, not just that we're doing, but dozens of other teams at Moorfields are doing. And you're right, could you implement this tomorrow? No, because they need to move to virtual clinics and all kinds of other better kind of service provision. But you kind of get a sense that the NHS, there's a real need for us to do this now, when I think a couple of years ago there was maybe, wouldn't it be nice if this worked? There is now a crushing need. Ophthalmology, 10% of outpatient appointments, increasing by double digits every year. There is just a view now that we have to not just have the clever algorithms, but also the service reconfiguration around it to make it a success. And I'm optimistic about the digital innovation hubs. The focus to say we're going to dedicate resource and expertise and support for half a dozen key areas, rather than kind of spreading money around in a way that I don't think ultimately delivers real value. So I think we're actually going to see a lot of progress in the next couple of years, but it won't be easy.
And if I may just add one more thing to that, there is this positive reinforcement loop. So if you can prove that on improved quality of data, you get reasonable insights, you can actually ask clinicians to think about the data as they input it, to actually care for that, because they will see the benefit of this work. It's very hard to do it when it's just a void there.
So we touched a little bit on this with Rabia's example, but also kind of the need for working in partnership. And everyone's very excited at the moment of this idea of kind of the value of NHS data. And as I think most people on the panel would agree that there's kind of pockets that are quite valuable, but often it needs a lot of work, a lot of cleaning, a lot of curating, like most data sets do. So whilst the kind of value of data discussion is quite a kind of interesting, cerebral and intellectual discussion, it's quite a hard thing to really do in practice. So a question for you, Rabia, can you give a little bit more detail in terms of how you did this in Oxford? And also for other members of the panel who've had an attempt to having these sorts of discussions, how you navigate kind of these things and hurdles that come up from these value of data discussions, like if that you're baking in conflicts of interest into the system, how do you build a competitive case for value of data? So can we have a bit of an example from Oxford with a bit more detail, if that's possible?
For the Sensyne Health model, Oxford was the first NHS trust that we partnered with. Now there's 5, whereby we work with the trust and we're able to access ethically sourced anonymized patient data. And use that information for the pharma R&D process. So we spend a lot of time right now talking about how do you build an application and deploy it back into the NHS. That is part of what Sensyne Health does, but what I'm most interested in is using that data to inform something like a clinical trial. So ASCO recently happened, and there was some really incredible research showing how real-world evidence, NHS patient records, can be used to look at responders and non-responders for really expensive immuno-oncology drugs. You can start thinking about patient stratification. And the example that I love the most in the pharmaceutical process is that it takes, I think it's $2 billion in 10 years to get a drug to market. And most drugs are built for white males. And so how do we start using real-world evidence to start looking at patient heterogeneity in reality, because all people are not white males, something I care about a lot, being born and raised in Pakistan. And so we can start using real-world evidence to start actually driving impact across the drug discovery pathway, and that data is valuable in that setting. Definitely to train ML algorithms to deploy in, but I think there's a whole other value that sits in that ecosystem that we haven't tapped yet.
So what do you think, what was it about Sensyne that made that discussion and collaboration effective? Because lots of people are trying to do it, but arguably you guys have been some of the most successful. So I appreciate it was maybe a bit before your time, but what was it about the Oxford ecosystem that meant that it was a kind of mutually beneficial partnership?
Absolutely before my time at that company. I think it has a lot to do with the CEO, Paul Drayson, who was, I think, science minister at the time, at one point, but also the ability to demonstrate that people care about this asset. We don't know yet if people care about it. How are people going to monetize NHS data? It's all about it's valuable, but we don't know how, and we're still trying to figure that out.
Yeah, I mean, from our perspective, I'll say again, these algorithms wouldn't work without data, so there's no question that you need data to power them. I would say that what makes the NHS and the amazing hospitals and universities that we work with attractive is actually much more around that expertise, which is both research, clinical, information governance, the whole remit, and just on like value back, which I think is essential, like that. Companies like ours get this right, but people talk about IP, and I think what they're talking about really is a proxy for value. And if I just, this is something we've thought about. I know we've had discussions about Maxine, but I think there's many ways of giving value back from this type of work. Okay, so and I'm just going to list a few of them. Now, you could do a direct payment, and I'm not sure if we think that's something the NHS wants to do. It certainly happens in other parts of the world. It's something that we've steered clear of for many, what I think is good reasons. But you could do direct payments. It's important to say that if you go down that perspective, the cost, as is the case for most types of data, is falling. So whether this is something that, as some commentators say, is going to support the NHS, I think I would question that. Okay, so you could directly pay for it. Capability building, I think, is a really important value back. So if you look at Muirhead, whether it's the types of people they're recruiting, the types of research that's being funded, I think there's enormous capability building that these partnerships can bring. There is what is actually most important to most health systems we work with and providers is delivering better care. We will publish results in the next few months that show this. These technologies improve care and reduce costs, and I think it's really important to say that that's actually the ultimate aim of a system like the NHS, and companies like ours would maybe benefit from sharing in some of that value created. And then you get into revenue shares and IP shares, and there is huge expertise in different ways of doing that, but it's something that most companies are willing to discuss, but it's not as simple as saying let's do an IP share. There's just a lot more complexity to that discussion than saying let's do a 50-50 IP share.
So there's a lot of discussion about how do you make organizations more transparent, more open, more accountable, every other word in that kind of melange of trying to be a modern ethical corporate. And all of you are approaching each one of these kind of openness, fairness, transparency in slightly different ways. So it'd be really useful to get an insight in terms of something really concrete and practical that each of your organizations are doing to kind of actually present and do the ethics thing a bit more effectively than just pay lip service. Do you want to start?
Sure, yeah. I mean, we just speaking from a research perspective, we have teams looking at this. Kate Crawford in the US, helped found the AI Now Institute. We actually, within Microsoft, instituted something called the Ether Committee, which is a top-level committee within Microsoft that looks at our products to make sure that our AI products are ethical and that they're engineered correctly, and we're even putting in engineering requirements around AI ethics into our products. And when you think of Microsoft products, we have our cloud products, but it includes things like Windows, Microsoft Office, and so that's really important. And then also that committee looks at customer deals as well. So we have customers wanting to do things with AI, and that committee will have a look at those and see. So I think famously in California, we turned down a facial recognition project with the police department because the Ether committee didn't think there were enough guardrails against that. So yeah, very concrete, within that team and within that committee, we've got vice presidents in Xbox, vice presidents in Skype within Microsoft Research at the highest levels in the company, and then sub-teams looking across this, defining our strategy, and really putting concrete things in place, and then also working kind of externally. So we published a book called The Future Computed, which is a real book that you can get and download for free as well, which really goes through some of those principles. And we've even launched some online material called the AI Business School, which is a MOOC. It's about a 10-hour course with specific content on how you think about AI, how you think about ethics, how you actually implement that in health, in government, in finance, in retail. And so really doing a lot of work internally and making sure that what we do is the right thing. But then also, putting that material out there publicly and running training. And Brad Smith, our president, said we really think about not what technology can do, but what technology should do. And that's really kind of how we think about this.
As a young company, I think a year and a bit old, the company's AIM listed, so that allows you to have all of the criteria needed to be a publicly listed company. But more so than that, as a biologist, I have all kinds of really great questions that I want to ask of NHS data, but I'm actually not allowed to. We're only allowed to ask questions that have an explicit patient benefit. It has to go through all the Code-to-Cop Guardian internally within the NHS trusts. So there's a lot of checks and balances before we can even access anonymized, ethically sourced patient data. Just that is the infrastructure that was set out. It's non-negotiable within Sensyne Health.
I will give a very simple technical engineering answer. For me, the great example is the audit part of the product that we are building. So actually an ability for the hospitals that we are working with, for the patients, to literally see every single access to the data that is happening. And I think it's through this kind of low-level trust-building mechanisms that we will be able to showcase on higher and higher levels, like how the data is being used, why, and for what purpose.
I think from a DeepMind perspective, recognizing that we're going to the health part of DeepMind is transitioning across to a wider Google Health effort. I think we were in a very privileged position a few years ago at the start of this thing, and with the kind of independence of DeepMind, to think about things in a way that, as you know well, Maxine, probably no company has thought of like before, the independent review panels, publishing contracts, etc. Now, the person who's come in to lead health efforts across Google, David Feinberg, is a physician, health system leader, and he absolutely recognizes the importance of, we are not going to be able to do any work in healthcare unless we build trust and safety into everything we do. It is to be seen, and we're very much part of the discussions. I sit on the executive team for the Google Health efforts. How we bring that kind of stuff in. There's definitely parts of it that are just not going to be possible as you think about a global effort as opposed to something we're doing in the UK. Can you have an independent review panel that sits in London judging what's happening in India or Thailand? Probably not, but we're thinking carefully about how we bring that in. There's other things that commitments to publishing, putting your protocols up online, being measured against that when you come to publish your papers. I would love to stand up and talk about the other 6 projects that we're working on. You can find details of that on our website that detail the projects, but until we've actually published that and allowed the academic community to kind of critique it, I think that's an important part. And actually, this is different for what a normal product-focused company would do, and I know Microsoft and many other companies do it too. But I think our companies need to adapt to working in health, And maybe health can learn a bit as well from the way companies like ours work in other areas too.
Dom, that's a fantastic segue to my final question. It's as if you'd seen this before. We've only got time for kind of closing off questions, but it's very exciting to look at big tech companies and their trendy sneakers and bean bags and tax evasion. So what is? Sorry. Anyway, but what in reality, what can big tech learn from healthcare? I'm going to start with you, Dom.
What can it learn from?
What can big tech learn?
Well, I think synergies first. Companies like ours, the fact that it has these products used by billions of people is because they focus on user needs. And I think it's all too easy to come into healthcare and think that we know better. And I think both by the recruitment of internal expertise, the setting up of and working with experts and patient groups. I think you learn. We have to learn. It's not like Google's never or Microsoft haven't been working in healthcare for the last year or two. They've been in one way or another doing it for many, many years. And I think this renewed interest in health has to come with. There is a lot of expertise that sits out there does not exist in our company, and we have to find new ways of partnering and working with people to really make this work.
I would say healthcare is all about the patient, ultimately about the one that receives the care. And if we could learn to have this attention to the user, to their data, to the outcome for them across all the industries, I think that would be the huge benefit of actually entering the healthcare space, which I think on one hand is the most challenging, but because it's so challenging, we can actually uplift the whole industry by working on it.
So I'm going to say what healthcare can learn from, what tech can learn from healthcare is to not do Theranos again.
Just as a general rule, don't do Theranos. Just really embody that, please.
But I think it's a regulated industry, right? There's a reason the regulations exist. There's a reason 10 years drug to market. How can we make that smaller, but at the same time not try and move fast and break things in the healthcare system?
Yeah, I totally agree with that. And I think, we're, again, as we look at healthcare, we have a lot of humility in terms of learning, from our partners. I don't know if we mentioned that Sensyne is our partner, so it's a great example of where Microsoft is really working with a partner, again, sort of locally with the NHS, but then we learn from that we can apply that in other countries, whether that's in Finland or in the US or Australia or India. So we certainly, that's why we have a partner-first strategy, so we can learn to make sure that we're helping to lift the tide for healthcare.
Perfect. So can you join me in a round of applause for amazing data pioneering time?